of carbon dioxide transport through this method. Transport through this method. 70% of carbon dioxide transport through this method. Transport through this method. 70% of carbon dioxide transport through this method. Majority of major part of carbon dioxide transport through this method. And near tissues. Near tissues. Near tissues. Near tissues. CO2 combines with CO2 combines with water. Near tissues, CO2 combines with water, which is present in RBC. Present in RBC. Here, just now we have discussed the dissolved state. You have to compare with bicarbonate state with dissolved state. That's why children listen carefully, and I would like to give the questions to you. You must be answer for those questions, ready to answer for those questions. And here you can take this is the plasma. Plasma. The blood containing plasma. This is the plasma. In the plasma, RBC present in the plasma. This is the RBC. RBC present in plasma. Here you can take RBC present in plasma. This is the RBC. RBC present in plasma. Plasma and RBC present. In the plasma, the RBC cells are present. When the CO2 present in the tissues, near tissues, just now I wrote, this is the tissue. Near tissues. Near tissues. The CO2 enters into RBC. If we will take the CO2, combines with water, and develops into H2CO3. H2CO3. This is a carbonic acid. This carbonic acid immediately split into HCO3 minus plus H plus. To occur this reaction, here enzyme is present, that is called as carbonic anhydrase enzyme. Carbonic anhydrase enzyme. Here also carbonic anhydrase enzyme is present. Carbonic anhydrase enzyme is present. In RBC, carbonic anhydrase enzyme is present in the RBC. RBC containing carbonic anhydrase. That's why more CO2 combines with water, and it must be transported through the water through the hemoglobin, through the water which is present in the RBC. But if you will take here, you can take the dissolved state. In dissolved state also, the CO2 combines with water. In this area also, CO2 combines with water, but only how much percent of CO2 combines with water? Only 7% of CO2 combines with water, and it must be transported through the water. But when we will take in bicarbonate state, here also the CO2 combines with water and develops into carbonic bicarbonate or carbonic anhydrase and bicarbonate, and it must be transported through the water which is present in the RBC. But in this method also, the CO2 combining with water, But here, how much percentage of carbon dioxide is transporting? 70%. But in the dissolved state also, the CO2 combines with water. But here, only 7% is transporting. Why? Why? Because there is a difference between dissolved state and bicarbonate state. There is a difference between dissolved state and bicarbonate state. In plasma, there is no carbonic anhydride in the plasma. That's why the carbon dioxide combines with water. Less amount of the carbon dioxide combines with water which is present in the plasma and transport through that water. But the RBC containing carbonic anhydride enzyme, the RBC containing carbonic anhydride enzyme, when the RBC containing carbonic anhydride enzyme, here the carbon dioxide, more amount of the carbon dioxide combines with the more amount of the carbon dioxide combines with the H2O, water, and it must be transported through this water. It must be transported through this water, and more amount of the CO2 transport through this water. This is the difference between dissolved state and bicarbonate state. I will give one or two bits about this. That's why listen carefully and remember perfectly properly. There is a difference. In bicarbonate state, 70% of carbon dioxide transporting. In bicarbonate state also, the carbon dioxide combines with water, but more carbon dioxide transporting this method. Why? Because the RBC containing a enzyme, the RBC containing the enzyme that is called as a carbonic anhydride enzyme. Due to the presence of carbonic anhydride enzyme in RBC, more carbon dioxide transporting through this method. This is the reason behind that dissolved state and bicarbonate state. Here, near the tissues, near the tissues, near the tissues, CO2 combines with water. Near the tissues, CO2 combines with water and it must be transported. CO2 combines with water which is present in the RBC. Here you can take plasma near the tissue. The CO2 enters into RBC. This is the RBC. And in the RBC, the CO2 combines with water. In the presence of carbonic anhydride, develops into H2CO3. Carbonic acid, H2CO3 nothing but carbonic acid. And it unstable, it's not stable. Immediately it must be split into HCO3 minus and H plus. HCO3 minus, this is bicarbonate. HCO3 minus, this is a bicarbonate. Bicarbonate. One thing also we have to remember here. When the H2CO3 is split into HCO3 minus plus H plus. Here, the HCO3 minus comes outside. Bicarbonate comes outside from the bicarbonate comes outside from the RBC. You may get that out. Sir, why it is coming outside? If the bicarbonate present in the RBC, if bicarbonate present in the RBC, some changes occurs in the RBC. Due to that, the RBC goes to spoil. That's why the bicarbonate comes outside. When bicarbonate coming outside, at the same time, chlorine ion enters into RBC. And it is also, this process also called as antiporter. Just now we discussed amphoteric, and this process called as antiporter. Antiporter. What is meant by antiporter? Through plasma, through RBC wall, through RBC wall, two substances changes into opposite direction. Changes into opposite direction. changes into opposite direction. The changing of two substances in the opposite direction through RBC wall. The changing of the two substances into opposite direction through RBC wall is called as antiporter. It is also most important for this purpose. Here you can take
Sir,
RBC wall.
I can't see the right side of the board, sir.
What, madam?
It's only half visible, sir, right side of the board.
Oh, half visible. Okay, now I am changing this. Here you can take. Okay, changes into through RBC wall. Two substances changes into opposite direction through RBC wall. Two substances changes into opposite direction. The changing of the two substances into opposite direction through RBC wall. Here you can take changing of two substances in opposite direction through RBC wall is called as antiporter. Here you can take when bicarbonate coming outside from RBC, to compensate this, the chlorine enters into the RBC, and this phenomena is called as chloride shift. The changing of chloride, the entering of chloride ion into the RBC, and coming of bicarbonate from RBC. The shifting of chloride ion into RBC, or the shifting of chloride ion and bicarbonate ion, is called as a chloride shifter. When in the chloride shifter, when the chlorine enters into the RBC, here you can take hydrogen ion is present, H plus ion. It must be combined with hemoglobin and develops into HSB. This is called as acid hemoglobin. Here you can take H plus ion buffers the hemoglobin. H plus ion buffers the hemoglobin. This is also most important for need purpose. H plus ion buffers the hemoglobin. H plus ion buffers the hemoglobin. Most important. Which ion buffering the hemoglobin? H plus ion buffering the hemoglobin. This H plus ion combines with hemoglobin and developing into HSB. HB, acid hemoglobin. If the H plus ion does not combine with hemoglobin, there must be changes occurs in the RBC. The RBC changes must occur in the RBC. That's why it must be neutralizing, buffering. The H plus ion buffering the hemoglobin. H plus ion neutralizing the hemoglobin, buffering the hemoglobin. This phenomena is called as a chloride shifter. The changing of the entering of the chlorine into RBC and the coming of bicarbonate from RBC. The shifting of chlorine and bicarbonate is called as a chloride shifter. And this phenomena is occurring in the tissues, and this RBC reach near the lungs. When it is reaching near the lungs, which phenomena is going to occur, we have to discuss. Before that, anybody want to once again, Nana? Very simple, Nana. The carbon dioxide combines with water, which is present in RBC, and develops into the H2CO3, and it must be split and develops into HCO3 minus H plus. Through RBC water, about 70% of carbon dioxide transporting. More part of the carbon dioxide transporting through this RBC water. Why? Because the RBC containing carbonic anhydrase enzyme. Due to the presence of carbonic anhydrase enzyme, more carbon dioxide combines with water, which is present in RBC. This is the reason behind the carbon dioxide combines with water. More carbon dioxide transported with water, which is present in the RBC. Here you have to remember that. And when the H2CO3 carbonic acid split into HCO3 minus plus H plus, the HCO3 minus comes outside, bicarbonate comes outside. If bicarbonate does not coming outside, if it is present in the RBC going to spoil. That's why it must be comes outside. When it is coming outside, immediately the chlorine enters into the RBC. The shifting of chlorine into RBC and coming of bicarbonate from RBC is called as the chloride shift. And this phenomena is called as anti-Porter phenomena. In opposite direction, the two substances must be changed. And this H plus ion combines with hemoglobin. H plus ion combines with hemoglobin, develops into HHB, acid hemoglobin. In this, the H plus ion buffers the hemoglobin. Most important thing. H plus ion buffers the hemoglobin. It was the question in previous MSET. Hemoglobin buffered by which ions? H plus ions. They will give sodium ion, chloride ion, bicarbonate. Such like here you can take H plus ion buffering the hemoglobin.
The buffering, what is the meaning of buffering?
Neutralize. Okay, Nana? Silence.
Okay.
Any doubt in this, Nana? In this area?
Sir, the chlorine, sir, how does the chlorine, sir?
If we will take the chlorine, actually the chlorine present in the plasma water. The RBC present in the plasma. Plasma is a water. In that water, the RBC cells are present. The plasma water containing chlorine, chloride ions, sodium ions, potassium ions, magnesium ions also, such like of ions are present in the plasma. When bicarbonate comes into the plasma, immediately the chlorine enters into the RBC. Okay, Nana?
Sir, why do chlorine ions enter into RBC instead of HCO3?
Okay, Nana. To compensate this ionic balance, when bicarbonate is coming outside, the negative charge is coming outside. To compensate this, the chlorine enters into the RBC. Okay, Nana?
Okay, sir.
When the RBC reach the lungs, this reaction occurs in opposite direction. When RBC reach the lungs, here you can take. When RBC reach the lungs, when RBC reach the lungs, here you can take RBC. RBC reach the lungs. Here you can take, these are the lungs. Lungs are nothing but alveoli. This area alveoli are lungs. When RBC reach the lungs, in this which is present in CO2 combines with H2O, develops into H2CO3, immediately split into HCO3 minus plus H plus. Actually, the chlorine present in this chlorine, the HCO3 already is present it came outside. But when it reached the lungs, here you can take near the lungs, H place near the lungs, H place combines with HB and develops into HB. When it reaches the lungs, immediately the chlorine comes outside. The HCO3 minus enters inside. When HCO3 minus enters inside, when HCO3 minus enters inside, and it must combine with which it must combine with when HCO3 enters into the RBC near the lungs. When HCO3 enters into the RBC near the lungs, it must combine with H place and develops into H2CO3. Develops into H2CO3. Develops into H2CO3. The H2CO3 immediately split into CO2 and H2O. The CO2 enters into the carbon dioxide. The carbon dioxide enters into the lungs and alveoli. It must be eliminated outside through the nostril. This reaction is occurring near the lungs. This reaction is occurring near the lungs. This is called as transportation of carbon dioxide through the bicarbonate state. I would like to give this information once again. Listen to me. If we will take carbon dioxide, just now we were discussed, it enters into RBC, combines with water, enters into RBC, combines with water, develops into H2CO3. Carbonic acid develops. The carbonic acid is stable substance. It's not stable. Immediately breaks into HCO3 minus plus H plus. HCO3 minus bicarbonate. It won't stay in RBC. It must be comes outside from RBC. When it is coming outside from RBC, immediately the chlorine ion enters into the RBC. Immediately chlorine ion enters into the RBC. This phenomena is called as chloride shift. Just now we were discussed. The chloride shift, otherwise called as Amberger phenomena. Amberger phenomena. Amberger phenomena. Amberger phenomena. Chloride shift, otherwise called as Amberger phenomena. Amberger phenomena. This is also most important. Amberger phenomena. Chloride shift, otherwise called as Amberger phenomena. Amberger phenomena. This RBC reaches the lungs. Near the lungs, the bicarbonate enters into RBC. When bicarbonate enters into RBC, immediately the chloride ion comes outside. This bicarbonate combined with H plus ion develops into H2CO3. Develops into H2CO3. The H2CO3 immediately split into CO2 plus H plus. CO2 plus H plus. The CO2 enters into the lungs through the alveoli. CO2 enters into the lungs through alveoli. It will comes outside. It will comes outside. This is about transportation of carbon dioxide through which state nana? Bicarbonate state. Transportation of carbon dioxide through which state nana? Bicarbonate state. Forward anybody want to answer nana? Students?
Poetry.
I will give the questions to you. I will give the questions to you. You have to answer for those questions. If you understand perfectly, you are able to answer. Otherwise, you won't. Follow them.
Yes.
Okay. May I give questions from this area?
Yes.
Okay, right. Listen and look at the board. Most of the persons are going to get the confusion in this area, Nana. That's why listen carefully. It's very simple actually. It's very simple actually. Listen to me, Nana. Okay. I'm giving a simple question at first now. Listen to me. RBC contain dash enzyme. Here you can take carbonic anhydride. Listen carefully. Look at the word perfectly properly. I am confusing you. Here you can take carbonic anhydride. Third option, carbonic acid. Fourth option, none.
Sir,
What is your
second
answer,
option,
Nana?
sir. Second option, sir.
Very good, excellent, Nana. You won't confuse you. Generally, anhydride, here also anhydride and there also anhydride, but a word, a single letter is different. En. Good, very good. You are observing very well, Nana. Excellent. Excellent. Good, Nana. Good children. Very good. Okay. Now we have to discuss a different question I am giving. If plasma contain more carbonic anhydrase, enzyme than RBC. What happens? Here you can take first option. Only 7% of carbon dioxide transport through the plasma. Through plasma. And here you can take more carbon dioxide, more CO2 transport through plasma than RBC. Water. Here you can take third option. No change occurs in transportation of CO2. And the fourth option, RBC water transport more CO2 than plasma. What is your option, Nana?
Second option, sir.
Second option. Give confidently. Of course, if it is first, second, third, whatever it may be, give confidently. Give the answer confidently. Children, just now we discussed Are you giving? Are you saying confidently? The second option is correct. Children,
Sir, I
give
don't
any
know the
answer.
answer, sir. I
Okay,
don't
okay,
know
okay, right.
perfectly.
Okay, right. Here, listen to me. Second option is correct option, Nana. Who gave this answer? Who told me?
Tejasvi, sir.
Good, very good. Second option is the correct option. Why? Because just now we discussed the carbon dioxide transport through two methods, the three methods actually. First one, dissolved state. In dissolved state also the carbon dioxide combines with water. In bicarbonate state also the carbon dioxide combines with water. But when we will take the dissolved state, through the dissolved state, only 7% of carbon dioxide transporting. But if we will take the bicarbonate state, in bicarbonate state also the carbon dioxide combines with water, which is present in RBC. But 70% of carbon dioxide transporting through this bicarbonate method. Why? Because RBC containing which enzyme? Just now we discussed carbonic anhydrase enzyme. Due to the presence of carbonic anhydrase enzyme, more amount of carbon dioxide transport through the water which is present in RBC. Just now we have discussed. In this you can take if plasma contains more carbonic anhydrase enzyme. Actually, there is no carbonic anhydrase enzyme in plasma. The carbonic anhydrase enzyme present in the RBC. That's why the RBC water transporting more carbon dioxide. 70% is carbon dioxide. But here you can take if the plasma contains more carbonic anhydrase enzyme than RBC. Actually, the carbonic anhydrase enzyme present in the RBC only. But here I am confusing you. If more carbonic anhydrase enzyme present in plasma than RBC, where there is a carbonic anhydrase enzyme, there the carbon dioxide combines with water in more amount. That's why here the plasma containing more carbonic anhydrase enzyme. That's why more CO2 transport through plasma than RBC. That's why our second option is correct option, Anna.
Sir, I didn't understand the options, the second option. It is telling that more carbon dioxide transport through plasma than RBC.
Yes, sir. Why? Because why more carbon dioxide transporting through the plasma? Why? Because here which is present carbonic anhydrase is present in plasma more amount. That's why more carbon dioxide is transported through the plasma. One thing you have to remember, Nanu. If the water containing carbonic anhydrase enzyme, more carbon dioxide combines with water. But actually in the bicarbonate state, the RBC, just now we have discussed bicarbonate state, 70% of carbon dioxide transport through this method. Why? Because the RBC containing which enzyme? Carbonic anhydrase enzyme. And the question may become as like this also. If here I would like to give one more question. If RBC, if carbonic anhydrase absent in RBC, if carbonic anhydrase enzyme, if carbonic anhydrase enzyme absent in RBC, what happens? What happens? Here you can take first option. More CO2 transport. More CO2 transport. More CO2 transport. Second option. No change in transportation of CO2. No change in transportation of CO2. Third option. Less CO2 transport. Less CO2 transport. Fourth option, none.
Third
Okay,
option,
what is
sir.
option?
Less CO2
Good,
transport, sir.
Good, very good. Less CO2 transport. Very good, excellent. Likita followed Nana. Why? Because
Yes, sir.
carbonic anhydride absent in RBC. You will get the doubt. Sir, if carbonic anhydride absent, less CO2. Why less CO2? The RBC also containing water. Just now I drawn the diagram. RBC also containing water. Due to the presence of carbonic anhydride, the RBC water supplying more carbon dioxide. But here carbonic anhydride absent in the RBC. That's why the carbon dioxide combines with less carbon dioxide, very less bit of the carbon dioxide transport through this method. Why? Because carbonic anhydride is absent. Anhydride enzyme is absent. So the transportation of carbon dioxide through the RBC water depends upon carbonic anhydrase enzyme. Carbonic anhydrase enzyme. The RBC containing carbonic anhydrase enzyme. That's why through this method, 70% of carbon dioxide transporting through this method. 70% of carbon dioxide transporting through this method. Followed, Anna? Anybody want to once again?
Yes, sir.
Followed, sir.
Followed, sir.
Okay, now we have to discuss about regulation of respiration. Regulation of respiration. Regulation of respiration. Regulation of respiratory system. Regulation of respiratory system. Regulation of respiratory system. Regulation of respiratory system. Four areas are regulating the respiratory system. They are respiratory rhythm center, respiratory rhythm center, rhythm center, respiratory rhythm center. Next one. Pneumotaxic center, pneumotaxic center. Next, third one. Chemosensitive area, chemosensitive center. Fourth one, receptors present in 1 minute. It is going to close within 1 minute now. Receptors, receptor close out within 1 to 2 minutes.